Hello, my name is Corey Wade. I'm the director and founder of Berkeley Coding Academy, where we teach data science and AI to teens from all over the world. Today, I want to answer some questions put forward by German and American homeschool families. First question, what was your first computer? That's a good one. Let me tell you a story. I remember going with my father to the University of Milwaukee, Wisconsin when I was a boy. He was a professor there. I remember when he would drop me off at the library and he showed me how to use the new Apple computers. Now, the Apple computers had a brand new technology at the time that was very cutting edge. You know what it was? It was a mouse. I'd never used a mouse before, and I was really impressed with how easy it was to create drawings and use different colors. And I had a good time doing that. Next question. Why study data science and programming? Look, programming is a form of empowerment. Instead of always being on the receiving end of technology, you can be on the creating end. Now, when it comes to data science, which is a particular branch of programming, we're talking about 2.5 quintillion bytes of data that are being generated every single day. We are in desperate need as a society for people to be able to analyze this data and make sense of it. The White House called upon the data science community to analyze tens of thousands of COVID documents. This is not some fad. This is an essential part of our growth as a species. To give you another example, on the side of research and science, astronomers are looking in the far reaches of the universe to uncover our origins, not only as a species and as life, but as universal matter. Now, when this is happening, what are they doing? In actuality, they're analyzing data. So we need data scientists, not just to make sense of the world today, but also to drive the world that we're going to be coming into tomorrow. Why is BCA unique? I can give you two reasons. First of all, I'm a teacher, and BCA is a business built by educators. So that in itself is not common in the data science world. And the second piece is that we're teaching teens cutting edge skills of value in the world today, in particular data science and machine learning. Now, what makes this unique in that sense? Well, I can tell you this. Most data science programs are geared toward college graduates. They expect you to have X, Y, and Z and this and that. And I've even heard people say, what value can teenagers possibly get out of data science? You know, I'm taking multivariable calculus and we're using the gradient and things like that. It's the difference between, in my mind, teaching someone how to build a jet engine and teaching someone how to fly jets. At BCA, we teach people how to fly jets. And the teaching that happens is based largely on my own experience, which is over 16 years of teaching teenagers in education. What is the flow of a typical class at BCA? Well, to start the day, we typically have an interactive lecture. That's me presenting a new topic, and then students are coding along with me. So it's not a passive lecture, it's interactive. After that, students break off into small cohorts where they problem solve and work on problem sets together. Followed by that, there's typically a bonus time, which could be anything. It could be team building within the cohort, or it could be presentations on a peripheral topic based on the expertise of the staff. Then for the second half of the day, we repeat that same process. So we try to keep it mixed up and fresh for all of our students. And that's exactly how our summer program is run. Does a student need to be local to BCA, or is class conducted virtually? One of my favorite things about BCA is that class is conducted virtually, which means that you can join from anywhere in the world. Note that in 2021, our classes will be live, however, so you need to be able to accommodate standard Pacific timeframes. what is machine learning in relation to programming, data science, and AI? That's a great question. So at the bottom, you have programming, right? There are a lot of different types of programming. You can program for games, you can program for math, or you can program for data. So when you get into data science, then you're looking at a subset of programming. Now, data science involves analyzing data, and it also involves a distinct component from data analytics, which is machine learning. And machine learning is making predictions from data, not using classical statistical methods, but using machine learning, which is using predictive algorithms that people have written. So machine learning is an even more specific subset of data science based on predicting. We're talking about predicting which way a car should turn at a given intersection, predicting whether an image is your face or somebody else's face, predicting whether you're going to click on something online or not, predicting whether a user is going to buy something or not, predicting whether an exoplanet exists based on the light fluctuations of a nearby star. Okay? And then when you look at artificial intelligence, we're actually looking at applications of machine learning. So it's not just the machine learning, which is the code itself. It's the technology. It's the self-driving car. It's the digital assistants that you interact with. It's the robot that may be going underground to look for relics in an archaeological dig. Okay, so again, there are a lot of types of programming. Data science is one specific type that looks at analyzing big data. Machine learning involves making predictions from that data, and AI attaches those predictions, which is code, into technological physical devices often. What is the demand in the workforce for skills in data science? It's really unparalleled. It's huge. Right now, you can go online and look. There are always thousands of data science jobs open, most of which offer over 6 figures. Every company pretty much wants data scientists these days. There are companies that are transforming so that they can hire data scientists. And you may want to know why. What's the point of this? It's because there's just so much data. You know, for instance, most companies have a website. Well, how do you know what's going on in your website? You've got data and you want people who can analyze the data. So that's kind of like a first step toward it. And then of course there are second steps, which are using that data to make predictions. And that's with machine learning, where a lot of the value actually comes into play. Data science is one of the hottest jobs right now, coming up in 2021. And it's been one of the hottest jobs in the last few years in the economy, where very importantly, you should know that the demand for data science jobs outstrips the supply. And this is very different than in academia, where the supply of professors is much greater than the demand. Next, you need to be great at math to pursue a career in data science. You need to be good at analyzing information and interpreting numbers. Do you have to be great at math? I would say not necessarily. A great programmer is not necessarily a great mathematician. There's some overlap in those fields, but I think there's also an issue with the way that we are teaching math today, and the way that math is really done at the advanced graduate level. So no, because let me just put it like this. If you want to get good at making predictions using machine learning, you want to get good at making predictions using machine learning. That's what we teach students how to do. You don't need to know how to compute the gradient of a neural network if you know how the neural network works. The reason why is because you're using the algorithm that somebody else has developed. And this is the way it is done. And what you're in effect doing is adjusting the parameters based on the results. So it's a very different ballpark. And again, what I'm talking about is the distinction between two things. It's, hey, how does the engine work? You know, what's going into that engine? How are they computing that gradient? Versus, hey, I'm a pilot. I fly the thing. And BCA would teach you how to fly. From the perspective of an educator, where are our schools falling behind and why? Well, we're talking about some cutting edge things today, like data science. And it seems that our schools are not delivering in those areas. Companies like Udacity, Udemy, Coursera, and DataCamp are creating their own programs and certifications because there is a clear tech skills gap between what tech companies want and what college graduates can do. Okay? So the gap is even larger than at the high school level, right? Where these topics are typically not introduced. But things are changing. UC Berkeley now accepts data science as an alternative to Algebra 2. In Los Angeles, the public schools are now offering data science as an option. So the value is in fact there. What schools need to do is start to keep up with the pace of what's going on in our society with research and industry in the last 5 years instead of teaching what we taught before. Now, as a math educator, just to give you one simple example, if I simply teach the same math that I was taught, say 25 years ago, there's certainly some value in that, right? But the world has also changed. So I think we need to give teachers more time, like at least 20% time, in order to continue with their own research and development so they can stay in front of the fields that they are working on. How much data science and programming should take place during high school? It partially depends on the student. I would say about 15% of the school day. You know, I think these skills are extremely valuable and important. You know, it's hard sometimes to find direct applications for something like, say, Algebra 2, right? So what can you do right now with the Algebra 2 that you're learning? And I'm sure you could come up with some creative examples. Well, let's just switch gears and say, what can my students do with the data science that they're learning? What I hope that they can do is they could analyze the COVID data today. They could produce unique graphs on that data and come up with original insights based on the data as it's changing on a day-to-day basis. So again, this is that difference between being on the receiving side of technology and information and being on the analytical and creative side. So I say 15% just as a rough estimate. I think importantly, they should be a part of the high school day, and we can all try to work together to help make that happen. Can data science and programming benefit a student interested in the humanities? Absolutely. One of my favorite branches of data science is called natural language processing. Now, let me give you one example of this, which is called sentiment analysis. So sentiment analysis can be used to perceive, say, the sentiment of something. So let's say that someone wants to analyze text to determine how racist they are. Well, if you look at a given document and you read racist comments in them, then you can say, well, this document is in fact racist. So sentiment analysis is actually used today to determine these types of things. They could also determine things like if something is sexist. It could also determine if people like or dislike something like a movie, which is what it's commonly used for. But this idea is that you can use data science to actually help determine this. Now, a historian can only go over so many documents over a lifetime by reading them. But a machine learning algorithm using natural language processing can go over as many as are available, and they can then perform tasks like sentiment analysis to actually analyze them. Another cool application is the generation of text, right? And we're starting to see this now where you have like dancing robots and poetry that AI is developing. And so I think we actually need more people in the humanities to get involved with data science and programming to show us some of the more fulfilling sides of life that data science and programming can bring. Do you view the relationship that we have with AI as ultimately positive and symbiotic? Yes. I think that artificial intelligence is better named collective intelligence. Let me tell you why. When Deep Blue defeats Garry Kasparov in chess, this happened 20-something years ago, it caught a lot of people's attention and it was kind of exciting. It's this competitive environment, man versus machine, and machine finally triumphed. But Deep Blue is like a collection of programmers, of people in the chess community, their chess databases, for instance. And there's also this history of, artificial intelligence, of machine learning, and of programming, of math and science that go into it. So in this day and age, when we're looking at the AI that's being created, like say a self-driving car, the goal there is to actually help us, one, get where we're going, but two, to become safer on the road. This is like the idea of man and machine working together. And I think these competitive, isolated environments like AI beats the Go champion are kind of fun and exciting, but it's not really the direction that AI is going. AI is actually, it's meant to enhance us, right? We're the ones who are coding it. We're the ones who are using it. Okay, so I think it is symbiotic, and it can definitely be positive, provided that we use it to do things that are beneficial to everyone, like keep people safe on the road, cure viruses that come out, and to help people. And I see that in a lot of the tech world today. What drives your passion for teaching data science to our youth? I am an educator, first and foremost. I guess I've always had a passion to kind of teach what I'm learning to others. And one of the reasons why I get so excited about data science is it's something new, like relatively new in the sphere of education. And I see that not enough people are doing it or know how to do it. And furthermore, I can say that when I learned how to do it, when I became trained in machine learning and data science and all this stuff that I'm telling you about, even Python programming, look, people, I learned this stuff like 5 years ago. Okay, I haven't spent my career on this. I've spent my career teaching. But when I learned this stuff, like it empowered me tremendously, and it gave me more to offer. And I want to empower our youth with it. I know what our teens do on a day-to-day basis because I work with them in the classroom in math. Solving challenging algebra 2 problems is really tough. I'm talking about rational equations like x plus 2 over x squared plus 5x plus 6 minus x over x cubed minus 1 equals x to the third plus 1 over x squared plus 6x plus 8. Solve for x. Yeah, should we be spending 60 hours of education on that? Maybe. But when you learn how to do that, you're learning how to get that card, that pass, to then take more classes in math, which, as someone who loves classical math, I actually like, but it doesn't serve most people. I think it would serve us better to actually help teens develop skills that are of value today. And learning how to analyze big data is of value today. With Berkeley Coding Academy, you will learn how to analyze big data, you will learn how to make predictions using machine learning algorithms, and you will have a fun time doing it, because that's where all the hard work comes in. That's where the passion comes in, and that's where my experience in education comes in. It's providing a smooth on-ramp to these, I would say, somewhat difficult fields that teens are more than capable of navigating. They just need someone or some people to show them the way. And at Berkeley Coding Academy, that's what we're going to do.